Hello class, today I'm going to show you how deal with contacts. I don't know what type of simulation you are going to have later in your future projects, but if you had a contact between two different geometries with different materials, what should you do? How finite element is going to deal with it? So let's start with Workbench. Yes, 2019, so it means I'm creating this video from home, and because I'm using this version, the free version, I'm going to have very limited number of mesh, and but you can improve mesh in university lab and have a better quality results. Okay, let's start with static structural. Engineering data. As a default we have structure still. I would like to add another material, a little bit softer. Let's see what we have here. I can select aluminum, Poisson ratio 0.33 and Young modulus and copper. Yeah, I'm going with copper. It is a little bit softer. So two materials, both metals, so there's just a little bit difference between the those two material. Okay, let's go back to the project. For geometry, I already draw something. If I could find, yeah, it's design number 1. It is very simple. We are going to see it. Let's open. I want to be geometry as simple as possible and small as possible because I don't have license to generate a large number of mesh. So simple as much as possible, small as much as possible. Let's see what I draw. So this is our geometry. Let me spin it. It is like this. I want to cut all of these to half and then use half of it, because this geometry won't be easy with this limited number of mesh. So let's start with this part. Create a plan here. Move the plan, for example, up to this surface. Yeah, it's good. Finish it and then split the body. Which body? I'm talking about this one, using this plan. So I have this. Let's suppress this for physics and hide it. Okay, now I'm going to start creating another plan here, moving it downward, for example up to this level, and again split that body, this body, using this plan. Did I select a body? Oh, I already locked it here, so that is why it says what's happening. Okay, now it's ready. So let's get rid of, which one is this? I want keep this one, and suppress this one. Okay, let me check once more if it's ready. Yes, and as you can see, the only contact is going to be here between this surface and this surface. Okay, Let's go. By the way, if you want to draw this, it is 100 millimeter by 100 millimeter rectangle, and I cut 40 by 70 here for both, and the thickness is about 30 millimeters. Let's open the model. I also can upload this geometry for you guys if you don't want to spend time to drawing. Okay, everything is ready. Let me check the material. Always you need to check the materials. I want to be the horizontal one to be a strong one, so structural steel, and the vertical one to be soft one. So I'm going to change the material to copper. So the vertical one is going to be the soft one. Let's go check the connection. Okay, the blue one is the vertical one, which is going to be soft one. Am I right? Let me check once more. Yes. So blue one was soft one, but here target is the blue one. Remember, if you want to investigate contact and do analysis about contact of two geometries, always select contact body as for the soft one and target body as a stiffer one. So for me, I need to change it. So contact supposed to be this one. Let's apply, and the target is supposed to be a hard one, this one, and apply. Now the blue one is the stiff one, and the red one is the soft one, which is the contact. So I'm happy with that. What else? The type of contact. We have several types. You already work with bonded, which means it's like a welded to each other. They're one body. But I want to have a frictional contact. When I say I want to have frictional, it comes with frictional coefficient. Let's go with 0.15 as a static and dynamic frictional coefficient. Okay, what is the behavior of this contact? Now I need to explain something here. Whenever you had a contact with two bodies, two geometries, you need to help ANSYS to understand that contact. If the stiffness between those two geometries or bodies are totally different, like when I say totally different, I mean one of them is steel, the other one is rubber. That big difference. If it's big different, when ANSYS comes to solve stiffness matrix around contact, everything, for example, here the horizontal one is a high stiffness, it's a steel, and then when it passes from the contact surface to the other one, all of a sudden it's going to be drop all the stiffness, and it is going to be like a rubber, very soft thing. So if you have that situation, you need to tell ANSYS, by the way, if you are investigating the contact, it's asymmetric, and be careful to update everything. If they are similar or pretty close to each other, select symmetric. Here we have two metals, so I can go with symmetric. If you don't select this, program control is going to be at default, and automatically it is going to select symmetric. So I'm going to do it. What else? For advanced, we have formulation. Okay, let me open the options we have. Augmented Lagrange, pure penalty, MPC, normal Lagrange beam. These are different formulations we have. Okay, lunch is ready. Okay, we have different formulations for this contact. Let me show you some theory about contact. When I'm talking about contact, I'm talking about two surfaces, the red one and the blue one. And I already told you contact is going to be soft one. That is why they draw it as a like a bended. And target is going to be blue and stiffer one. When we have a contact, we have two options. Sometimes we have overlap like this. Sometimes we don't have any overlap. So kind of we can classify the formulations to two types, with overlap, without overlap. Let's see what are the formula we have, what type of formula we have. For example, for pure penalty, we have overlap. When we have overlap, we can simply find the force, this Fn, using the vertical or normal stiffness. And basically we are considering this overlap as a spring. We have a spring with a stiffness of K normal, and we multiply this K with this amount of overlap, the X, penetration X we have. So you multiply those stiffness to penetration, you get force. We call this method pure penalty. But if you use pure penalty, it is going to be really sensitive to this penetration amount and this stiffness. So if you didn't use smaller steps, this overlap may be larger, and it is going to create unrealistic forces. To improve that, they introduced this augmented Lagrange method. So they add this lambda term here to decrease the sensitivity of this formula to this the magnitude of contact stiffness we have, this K normal. So it is going to be a little bit much more controlled. And sometimes these are the methods with overlap. Sometimes we don't have any overlap. So when ANSYS is solving it, there's two options. We have a contact, we don't have a contact. They're separate. So in those situations, when ANSYS solving it, sometimes those mesh is going to jump between those two, and it is going to create some oscillations for us. And we call this oscillation chattering. That is why sometimes they consider to have a little bit of penetration to avoid that. So if you were interested of details of those different contact formulation, you can search it online and read all the details about these formulations. Okay, let's go back. So you need to select one of the formulation. I'm going to select this augmented Lagrange for now. What else? Tolerance, not important. Oh, that one. This one is also interesting. This pinball region, usually it's program controlled. I can select this radius. So let's see. Let's add 5 millimeter, for example. As you can see here, now I have a ball, a pinball with 5 millimeter diameter there, radius there. So what is the application of this? When ANSYS solves node by node the contact simulation, ANSYS is going to say, okay, let's check. I'm solving force for this node at this contact. How many nodes are in contact with this node? Okay, ANSYS doesn't know the geometry, so it's just pure math. It is going to start looking for those nodes, check them based on the x and y and z to see if they are in contact with this node. And it is going to be like 1,000, depends on the number nodes you have. It's going to be a lot of calculations. But we know it's not necessary. You can see the geometry, and you can tell ANSYS, by the way, if you are looking for the contact for a node, look for just 5 millimeter left, right, top, and bottom. Don't go all over the geometry and look for it and waste our time. So you can select this pinball. And yeah, so now we are done with contact. Let's check our contact. We can check our contact using this contact tool. Okay, now I'm going to right click on contact tool and generate initial contact results. So basically ANSYS is checking it. The status here is close, close. We don't have any open contact. If we had any trouble here, ANSYS is going to show us using these colors. You have this type of error, fix it, and those kind of things. Let's go and check the mesh. I don't know how many extra mesh I could add. Let's go from coarse to fine and try it. It didn't change. I don't want to risk later after finishing this this simulation. I'm going to try to have a finer mesh as much as this license of ANSYS let me. Okay. Now, analysis setting. We are going to have 1 second of simulation. I can let it ANSYS to apply all of a sudden that the whole force and give me the results, or I can control it. Let's turn on auto time stepping, and I can say initial 100 step, minimum at least go with 10 steps, and the maximum, for example, 500. Don't go more than that. And am I going to have a large deflection? Yeah, probably. Let's let ANSYS know I'm going to have large deflection. Okay, let's add some solutions. Okay, total deformation, definitely. Directional, it's a good solution. And stress, equivalent stress. Let's solve it. I'm going to check the convergence. This is the force convergence, and this is force criteria. It's always under the force criteria, so it's converged. And we don't have any problem. But the mesh was so coarse, that is why it's not happy. Let's see the total deformation. 100 frame, 10 second, play. Why it's moving downward? Okay, I forget to include any support or force, so it's not doing anything. Let's add support. So fix support for this one and this one, and I'm going to add force here and here to stretch that soft one. So force, please apply here and here. Geometry applied. I want to know the direction, so component, At x direction, let's go with 100 Newton. And I want to make sure it's not moving up and down. So let's have displacement. Why not? Select, for example, this edge, apply. And I'm going to say this edge can move just in x direction, not in y and z. So not y, not z. So basically I just letting this geometry to move in x direction. Now it's time to solve. Let's check first convergence. Yeah, we don't have any trouble. At the early stage it couldn't converge, and then start converging, and the convergence is under first criteria. Happy. So ISO Z, let's play. This is total deformation. Yes, we have more deformation at the top side of this copper C shape. Okay, let's stop it. Let me show you. These are the 15 steps I had. I can go, for example, for number 5, select this one and retrieve the information for that one. Okay, let's go for the last one. Retrieve these results. Okay, let's go. Oh, direction deformation in x direction. So still we have highest there, and equivalent stress at the top. Let me hide one of these and check the stress there. And yeah, because we have very large mesh, we can see that much details, but it's still as we expected. In the contact area, at the center of contact, we have higher stress there. Okay, let me take this one back. Now let's add a contact tool. And for contact tool, this is the status. I want to know what's the pressure at the contact. And let's update. Now I can see the pressure. Zoom. As you saw, we had a larger deformation at the top side of C-shaped geometry. So because of that, we have a higher stress or higher pressure at the top side of the contact area. And this is our status, which is this. The red one is the sticking, the orange part is going to slide, and the red one are the area near the contact, and this is the far. So basically it's just a status of the contact, and this is our pressure. Yeah, if you wanted, improve the mesh quality to have more data. Okay, so during this video, I told you a little bit about the contact basics, what are the formulations, how we deal with it. Next time, I'm going to give you a little bit more details. See you next time.